students, welcome back once again to my maths class. In this video session, we are going to discuss the problems based on exercise 7.3 of coordinate geometry. We have studied the previous parts about the distance formula, area of triangle using the Heron's formula, the section formula, and so on and so forth. Now, in this video session, I'll be discussing with you the exercise 7.3. This exercise is based on the previous video session, that is the area of triangle, in which we have derived the area of triangle and also the Heron's formula. Let me have a quick recap of the Heron's formula and also the area of triangle. Now, area of triangle, let us have the recap. Now, area of triangle is half mod here. Do not by heart, I have told you. It is a simple way. Keep this cyclic form. x1, x2, x3. After 3 again 1. That is called cyclic, isn't it? So, x1. Keep a bracket. After 1, y2 minus y3. Now, plus x2 to y3 minus y1. So, what am I doing? 1, 2, 3. 2, 3, 1. That simply cyclic form. x3 you start. y1 minus y2. This is the formula when the coordinates are given. Now the Heron's formula, area of a triangle according to Heron's formula, s minus a, s minus b, s minus c, wherein s is the half of the perimeter. Okay, and where a, b, c are the sides of a triangle and half of the perimeter is s. So this is the Heron's formula. Now with this quick recap, let's start the exercise problems. Now I have written the first problem on the board for you. See here, find the area of the triangle whose vertices are 2, 3, minus 1, 0 and 2 and minus 4. So just by simply applying the formula we get it. Now let us suppose this as x1 y1, x2 y2 and x3 y3. Right. Now the formula, area of a triangle, is half mod x1 y2 minus y3 plus x2, after 2 immediately write 3, y3 minus y1, after 3 1, okay, plus x3 y1 minus y2. Right, this is the formula of the triangle. Now we will substitute all the values of x1 y1 and all the 3 values right here. Half mod, what is the x1 value? 2, y2 minus y3, here 0 minus of minus 4, right, plus x2 value is minus 1. So since here plus, I am keeping it in bracket. y3 y1 minus 4 minus 3, right, plus x3 value is 2, y1 minus y2, 3 minus 0, right here. Now we will do the simplification. 2, so 0 minus 4, that is minus 4, simply plus and minus, that comes to minus 1. 1 if you multiply, it is 1 into minus 7, so plus 2 into 3. So this comes to minus half, minus 8, minus 1, minus 7. So this is minus 7, this is minus 1. Comes to plus 7, multiplied, plus 6. Right. So that is half minus 8 plus 13. So this comes to half into 13 minus 8 is 5. Okay. 13 minus 8 is 5. Here, there is not minus here, sorry. So 5 by 2, that means 2.5. Since this is area, you have to write square units. So like this, using the formula, we can find. Pause the video and note it down. Let's see the next problem. Now the second problem, find the value of k for which the points are collinear. Now the points are given. Now these points are collinear and we have to find the value of k. K is placed in y3 place. Okay, so we have to find the unknown value k. Now given condition is that these points are collinear. Now collinear means they are placed on one line. All the 3 points are on one line. That means they cannot form a triangle. If the points are placed somewhere not on the same line, then only we can form a triangle, isn't it? So if the area of the triangle is equated to 0, that means those points are collinear. So here we will write, this is x1 y1, x2 y2 and x3 y3, right? Now here, since points are collinear, that is delta must be equal to 0. The delta is nothing but area of triangle is 0. So what is the area of a triangle? Formula half mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So this value, this area, if it is 0, that means the points are collinear. Given they are already collinear, that means this is surely 0. From this we have to find the unknown term y3, that is k. Now we will substitute. Now if I cross multiply 2 to 0, the value there becomes here. If I multiply this to 0, so 2 into 0 is 0. So simply this value will be left over. x1, I'll substitute the value of x1 7. Right, y2 is 1 minus y3 is k plus x2 value is 5, y3 value is again k minus y1 is minus 2, right, plus x3 value is 3, y1 minus y2 minus y2, so minus 2 minus 1. So this now half, this 2 I have multiplied there, so this is 2 into 0, that comes to 0. Now here we will open the bracket, 7 into 1 7, 7k plus 5k minus plus 2 into 5 is plus 10. Now here so minus 6 and minus 3, or else minus 3 into 3, that comes to minus 9. Likewise also we can take. So this is 0. Now we can take the mod also. Now here all the k values and all the constants I will join. 7 plus the constant is again 10. 7 plus 10, 17. 17 minus 3. 17 minus 9. All these are constants, isn't it? So 10 minus 9, 17 minus 9. That comes to 88. Okay. 7k, 5k, 2k. Now here 7 plus 10, 17. 17 minus 9. That is 8. 8 and 7k, 5k. That is minus 2k equals to 0. So 8 equals to 2k. So 8 by 2 is equal to k. So the k value is 4. Okay. So from the property of collinearity, collinear means area of the triangle is 0. So like this we will do the sums of collinearity. It's important for examination point of view for 2 marks, right? Quickly pause the video and note it down. Find the area of the triangle formed by joining the midpoints of the sides of a triangle whose vertices are 0 minus 1, 2, 1, 0, 3. Find the ratio of this area to the given triangle. Now we have to find the area of a triangle and also area of the triangle joining the midpoints, and also find the ratio of this area to the area of the given triangle. First, there are 2 triangles here. One is embedded in other one. Let me draw first for you. This is the triangle. Now let us suppose A, okay, 0 minus 1 given, B and C. Let me see the value of B. The second one is 2, 1 and the third one is 0, 3. Only this information is given. The vertices are given. We have to find the area of the. Now here area of triangle formed by joining the midpoints of the sides of whose vertices. These are the vertices. We have to find the, now here if the midpoints are, let me suppose the midpoints as D, E and F. Now joining the midpoints, we get another triangle. So that triangle we have to find the area. Then or find the ratio also of the big triangle and the small triangle. Now here, first to find the area of this small triangle, I need these three coordinates. How do I get the D, E and F? From the formula of midpoint. Right, now here let's start. Midpoint, we will write the formula first. Midpoint is equal to x1 plus x2 by 2 y1 plus y2 by 2. This is a midpoint formula. Now, midpoint of AB, that is D. Now, we will find D. Coordinates of D is the midpoint of AB, isn't it? So, I am not writing AB. This A is x1, y1. This B is x2, y2. To find D midpoint. So, directly I am substituting 0 plus 2 by 2. So, the x coordinates. Now, y coordinates here 1 and minus 1. Minus 1 plus 1 by 2. So, D is 2 by 2 and 0 by 2. So, that is 1, 0 is the D value. We found out D value, that is 1, 0. Right. Now, we will find the next, let me find the F or D. Okay. E will find E. This E is a midpoint of AC. So, this is x1, y1, this is x2, y2. So, 0 plus 0 by 2. Now, minus 1 plus 3 by 2. So, this comes to 0 by 2. 3 minus 1 is 2 by 2. So, this is nothing but 0, 1. This is E. Now, same as that F. F is the midpoint of BC. So, 2 plus 0 by 2 and 1 plus 3 by 2. Y coordinates. So, 2 by 2 and 4 by 2. That comes to 1, 2. This is F. Now, what we have to find? We have to find the bigger triangle area and the DEF area. Let us find. Now, first let me write the area of triangle. Area of triangle is half x1 y2 minus y1, no, y3. See here 1, 2 and 3 plus x2 y3 minus y1 plus x3 y1 minus y2. Okay. Let me find the area of triangle ABC, the bigger triangle. First one, the bigger triangle. Now, x1, y1, x2, y2, x3, y3. Now, we will substitute. For substituting, let me write here x1, y1, x3, y3. Right. What is the x1 value? 0 into y2, y3. y2 is 1, y3 is 3 plus x2 value 2. Isn't it? Now, y3, y1, 3 minus of minus 1. So, y1 is minus 1. So, plus x3 value is again 0. y1 minus y2. y1 is minus 1. y2 is 1. So, minus 1. So, this comes to half. 0 into anything comes to 0. Plus 2 into 3 minus of minus. So, 3 plus 1 into 2. That comes to 8. Isn't it? We'll write it as 8. See here. 3 plus 1, 4. 4 2s are 8. Now, 0 into anything is 0 again. So, this is half. If you remove the mod, into 8. So, this is 4 square units. The bigger triangle area. Right. Now, the smaller triangle area, DEF. We have found out the coordinates of D, E and F. Here, let me write down. E is 0, 1. 0, 1. And F is 1, 2. So, these we have found out. Right. So, we will apply. Here again, we will suppose them as x1, y1, x2, y2. right? x3 by 3. We will substitute here half. Now this is the formula. x1 is here 1 into y2 y3. What is y2? 1 and y3 is 2. 1 minus 2 plus. Now the second one x2. x2 is here. See the black ones. x2 is 0 into y3 y1. y3, see this one. y3 y1. 2 minus 1 plus x3. So y3 y1. So I have written y2 here. This is y2. y1 means 0, isn't it? So make this correction. This is 0. Now x3 value is 1. y1 y2. y1 y2. 0 minus 1. Right. Here. Now this comes to half. 1 into minus 1 plus 0 into anything comes to 0 plus 1 into minus 1 is again minus 1. This comes to minus 1. So that means half minus 1 minus 1. That is half into, let me write the mod, minus 2. Now applying mod, the minus value goes off, becomes positive. So 2 into 2 is 1 square units. Isn't it? The area of the smaller triangle is 1 square units. And also ask the ratio of their of the two triangles. Now here I'll write here ratio of the two triangles is, the first one is 4 and the second one is 1. So this is the ratio. Now first what we have found out? We have found out the mid values. From there the area of the bigger triangle, the area of the smaller triangle, then the ratio. Now quickly note it down, pause it. Fifth problem. Find the area of a triangle formed by the points 8, minus 5, minus 2, minus 7, 5, 1 by using the Heron's formula. Now I have drawn the triangle, noted the 3 points A, B and C. I have mentioned them as A, B and C. Now this triangle, area of a triangle is possible or not, we will see, but by using the Heron's formula only. Now if it is mentioned Heron's formula, we have to go with the Heron's formula only. We should not use the coordinates formula, right? Here, for finding the Heron's formula, just we have to find the distance. BC distance is A. Now the opposite to here, this distance and this distance, okay? That means the lengths. If you know the sides only, then we can apply it into the Heron's formula. Now how do we find these sides? Using the distance formula. Let us start the distance formula. I'll write it. It is x1 minus x2 whole square plus y1 minus y2 whole square. Right. Now I will find the distance, that are the sides, then we will apply the Heron's formula. Now, and this triangle area is possible or not, we will see. Okay. Right. Here if the distance formula of, now we will find the distance between AB, side AB. So for this, let me suppose them as x1, y1, x2, y2. Right. Now here in this I will substitute x1 8 minus x2 is minus 2 again. So whole square plus y1 is minus 5. y2 is minus 7. Minus of minus 7 whole square. This is under root. Okay. Now here this is 8 plus 2 whole square plus minus 5 plus 7 whole square. So this comes to 10 square and 7 minus 5 is 2, 2 square. So this is 100 plus 4. So 104 under root. Now this is not at all a perfect square. Okay. Now let us do one more side and let's see that whether this area is possible or not. If it is a perfect square, if the square root, or if you get a distance of some number, then only we can find the area of the triangle, right? Now let me take one more side, AC. Okay, if I want to find AC, this will become my x2, y2. Okay, this will become x2, y2. So let us take dash x2 prime and y2 prime, because it will be get confused with this. AC, for the distance AC, A is x1, x1 is 8 minus x2 prime is 5 whole square plus minus 5 minus 1 whole square. So that comes to 3 whole square and minus 6 whole square. So this is under root 9 plus 36. So this comes to 45. Right. Again, this is not a perfect square. 45 is not a perfect square, whereas 49 is a perfect square. Right. So it's not possible. So here you are getting under root 104 here. Here we are getting under root 45. Now the Heron's formula is nothing but delta. Area of triangle is S. S minus A, S minus B, S minus C, isn't it? So where S is half the perimeter. Now these values must be absolute values. These values must, A, B and C must be absolute. Here we are getting the not perfect squares though, so under root. So this triangle area is not possible. Simply write, it is not possible. Now why I have told the complete procedure, because if some other points are given in the examination, you can find using the Heron's formula. For this procedure to understand, I have told you, first any other points are given, so you can find using the distance formula all the 3 lengths, then apply it in S, then apply it in the Heron's formula. Okay. Now it is possible or not, by seeing the absolute values we can say. Right. With this we have come to the end of the exercise. I have left over for you the 4th problem, which and also few more bits. The 4th problem I want to give you a hint, because so that you have to solve for yourself. It is the area of a quadrilateral. Now any quadrilateral, like if you take any quadrilateral, right? So how do you find? We don't have any formula like. So what you have to draw? Just draw one diagonal. So it is parted into 2 triangles. Now find the area of this triangle, then area of this triangle. Just add them up. It becomes the area of the quadrilateral. So practice the 4th one with the hint they are given. So with this we completed the exercise problems. Do practice the sums, and we'll be looking forward in our next session with a new concept. Thank you.